We have this series sigma of 3n times n square over n factorial, which is an. We always denote the generic term. An is 3n times n squared over n factorial. Due to this factorial term, we are gonna use the ratio test for. We need the second term, next term, n plus 1, the next term, which is replace n by n plus 1. So this will be 3 raised to n plus 1 times n square now becomes n plus 1 squared over n factorial becomes n plus 1 factorial. So let me tell you about n plus 1 factorial. That's same as first n plus 1, first factor, second factor, 1 less n minus 1 all the way to 3 to 1. Okay, that is same as if we leave n plus 1 out here, n, now starting n times n minus 1, n minus 2 all the way to 1, 2, 1, 3 to 1, that's n factorial. So n plus 1 factorial is same as n plus 1 times n factorial. Okay, we have to use this fact in a moment. Now we are using the ratio test. Everything is positive, so we don't need absolute value. So limit n goes to infinity of an plus 1 over an. Okay, I put the absolute value, but it was not needed. Limit n goes to infinity of an plus 1, which is 3n plus 1 times n plus 1 squared over n plus 1 factorial divided by an. Divided by an is same as multiplying by the reciprocal of an. So find the reciprocal of an, which is n factorial on the top over 3n n squared. Okay, let's simplify, and there should be some cancellations. 3 raised to n plus 1 is same as 3 raised to n times 3 raised to 1. Okay, from the rules of exponent, whenever you have x raised to a plus b, that's same as x raised to a times x raised to b. Okay, so 3 raised to n times 3 raised to 1, don't have to write, times n plus 1 squared times n factorial on the top over n plus 1 factorial, which is same as that n plus 1 times 1 less factorial, which is n factorial. Okay, we found over here n plus 1 factorial is n plus 1 times 1 less than n plus 1, which is n factorial, times 3n times n squared. Okay, let's cancel a couple of things. 3n cancel, n factorial cancel. Okay, do not cancel n squared. Okay, now this is same as the following limit. Limit n goes to infinity of, what is left, 3n plus 1 quantity squared over, on the bottom, n plus 1 n squared. Let's multiply n squared n cubed plus n squared times n, just n squared. Okay, now this limit is kind of polynomial when we change n to x. So this limit, this infinite limit, depends on the leading terms. Okay, so limit n goes to infinity of leading term on the bottom, just n cubed. What is the leading term on the top? When we multiply n plus 1 squared by itself, okay, we're going to get n squared plus 2n plus 1. So anyways, the leading term is n squared, and when we multiply by 3, it becomes 3n squared plus lower terms, but the limit only depends on the leading term, and that is same as n squared n cubed. We can cancel, n squared cancel, just 1 left, so 3 over n. Okay, that's 3 over n, and when n goes to infinity, 3 over n, when n goes to infinity, 3 over infinity 0. Okay, which is less than 1. That means by the ratio test, the series converges absolutely. or in this case all the terms are positive, so the series converges.